Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve problem number 42 of GATE 2022 statistics paper. The problem says that a sample X is taken from the probability density function 2x by theta square, or X lies between 0 and theta and 0 otherwise. And we have to obtain the confidence interval for theta using X by theta as pivot. The the confidence coefficient is 0.8. So X is the PDF to X by theta indicator of 0 X theta. X by theta is to be used as pivot, and the observed sample is given as 10. So let us consider t equal to X by theta. So the PDF of t can be obtained by using the Jacobian technique of transformation. It is f theta t of theta into d dt of theta t, which is the following formula. We can obtain f as this sum f of fx of psi y into ddy psi y. For that, in transformation, x, let's it be psi inverse y. The transformation is y equal to ix. I is an invertible function, say. By using this formula, we get this. So we can obtain the PDF of t like this, which is of 2t for t lies between 0 to 2, and it is coming out to be independent of theta. Hence, we can use x by theta as a pivot. It is justified. Now observe that the 100 into 1 minus alpha percent confidence interval can be obtained in 3 ways, which is given as: one, we can take it from 0 to some c, where c is between 0 to 1, and we can also take from c to 1, where c is also 0 to 1, and we can take the middle part also, that is c1 to c2, where c1 is less than c2, and c1 c2 both lies between 0 to 1. So from the interval will be like 0 to some, that is here, this is the distribution of x by theta. So x by theta is lies between 0 to c. From that we can obtain the confidence interval of theta here from c to 1. So we can obtain like this: x theta less than x by c. So this kind of intervals we can get. But here in the problem, the confidence interval are of the not of the type 0 or infinity is anywhere. So we use the third form, that is the form c1 c2, or c1 c2 lies between 0 to 1. That is type figure 3. So let c1 c2 are such that probability of x by theta lies between c1 and c2 is 1 minus alpha. So we get the drawing as this. This is c1, this is c2, this is 1. So the PDF is this. So this is the interval. So now this area is 1 minus alpha. So this area will be, these two area will be equal. By convention we put it, this will be alpha by 2 and this will be alpha by 2. Hence probability of 0 x by theta lies between 0 to c1 is alpha by 2 equal to c2 to 1 is also alpha by 2. So from this diagram it is clear. So by integrating, we get c1 square equal to alpha by 2 equal to 1 minus c2 square, and hence c1 equal to alpha by 2 root square root of alpha by 2, and c2 is square root of 1 minus alpha by 2. Hence the 100 into 1 minus alpha percent confidence interval for theta is x by c2 to x by c1. where C1, C2 are both 0 to 1. C1, C2 are such that this condition should be satisfied. Now here given observed sample is x equal to 10 and alpha is 0.2, as we need to find 80% confidence interval. So here 1 minus alpha is 0.2, 1 minus alpha is 0.8, and hence we can get alpha equal to 0.2. So C1 is coming out to be square root of 0.1 and C2 is coming out to be square root of 0.9. So 80% confidence interval theta is 10 by root over square root of 9 to 10 by square root of 0.1, which is coming out to be 10.541 up to 31.623. So let us check which option is matching. So 10.41 and 31.6, hence option A is matching. Hence option A is the correct option. Now the objective of the problem is to find the confidence interval based on the given pivot. We first need to find that the pivot is actually, we can use the given transformed variable as a pivot because the distribution is independent of the parameter. And next step is to check which kind of interval we are considering here. That is whether 0 to C or C to 1 or C1 to C2, this kind of intervals. And then the finding the values of C, C1, C2, whatever you are using. So thus we can find the confidence interval for any parameter for any distribution. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.